There we go. I've hit record. All right, so here are your slide blank, insert pictures. Oh, I've actually wrote my department head an email. I've got an idea. I'm going to try to put a portable whiteboard in my house. Y'all should be ecstatic. I'm just kidding. That's what I am going to do. I'm going to try to do it and see if they don't have a connection. There we go. There's your basic. I'm going to pull it up in just a second. Now, y'all should know this. Okay, that's what we went over in chapter 2. All right. Now let's pull up the antiderivatives. And I only gave you a few of them. I don't give you all of them yet. This is just, right now, this is 2.1. So, slideshow. There we go. Wait a minute, dadgummit. Hold on a second. Supposed to be doing, not supposed to do that. And I can't. Can y'all see the slide?
Yeah.
Do y'all see the slide over here, and then you see this slide?
I see a blank slide.
I'm sorry, what?
I see a blank slide.
Maybe you're in a delay. Just give it a second. I don't understand how I get this turned off. Let me hit escape. Give me a second. I don't know why this is doing this. Okay, now let me hit slideshow. Let me hit there. Now let's see what happens. There we go. All right, now you should see just one slide. Should have basic derivatives on the left and rules for integrals on the right. Do you have that? Tell me if you got it.
Yeah. Got it.
Miss Billy?
I think mine's lagging for some reason.
Well, let me ask you this. Where do you live, Miss Billy?
You're like clicking on files.
Yeah.
Excuse
Where do you
me?
live?
I live in Powdersville.
You shouldn't be having a lag. Miss Cox, where are you right now?
Myrtle Beach.
Oh, hell no. You shouldn't be having a lag, Miss Billy. Because Miss Cox should be the one complaining. Mr. Nowak, where are you?
I'm in Connecticut.
Well,
Dang.
good God Almighty. Well, let me ask you this. Are you having a lag?
Nah.
Okay, there must be something wrong with your
I think it's
wireless.
just our internet.
Yeah.
I don't know what's wrong with our internet. We've been having problems with like Zoom and everything.
I'll tell
It
you
might
what
be
the problem is.
I'm
Your
probably
internet
too
has,
far away.
your wireless has the coronavirus. Mr. Reynolds, where are you at?
I'm in the good old town of Anderson.
Okay, I didn't hear a word he
We have
said.
AT&T.
I think he said he's in Anderson.
Okay. Your audio is jumbled up, but that's okay. Mr. Nowak, I got a question. Since Connecticut and New York and New Jersey are right there together, are y'all all dying off like everybody says y'all are?
Only like the southern part of Connecticut, like towards New York, is getting like pretty bad. But I'm like in the middle, and it's like not that bad. But like there's still kind of dying. But
Well, I think it's amazing how the flu has just disappeared. Have y'all noticed that? There's no flu anymore.
The coronavirus killed it.
Yeah, the coronavirus just killed the flu. There's no flu anymore. I guess I don't understand what's going on. I really don't. The flu just disappeared. We don't even talk about the flu anymore. And flu kills like 10,000 people, where the coronavirus only kills, 4,000 or whatever. I think I saw somewhere it's like 3 or 4 times the amount, but nobody talks about the flu anymore. So
Well, those are killing like the old people or people with like pre-existing health conditions, so they're kind of like the same thing.
well, yeah, that's what I've been saying the whole time. I'm like, the flu disappears and the coronavirus takes over. So anyway, don't even get me started because y'all think I'm crazy. So I'm not going to say anything. I'm just going to keep on going. Make sure you write down the power rule, the exponential rule, which I'm going to go over all this, and it's going to make a whole lot more sense after I do it because you know these rules. They make no sense the way they're written. So while you're writing that down, I'm going to move over to my next. I think I got some examples I'm going to do.
I mean, we live in a new house, so I don't know why we're having Wi-Fi issues. Like, we've only been in this house for like 3 or 4 years.
Huh. Who knows? You may have somewhere up there. You may have an optical cable broke or something. There may be an overload somewhere. But it hadn't always been this bad, has it? I mean,
No,
last week you didn't say
I
there
don't
was
know.
a
There's
delay.
something wrong. Yeah, there's something wrong today. I don't know if it's my computer. I just looked at my computer. It needs to update. That might be a problem too.
Okay. Well, the video, from what I've heard, the video is not lagging on YouTube. I don't think it is. They haven't. A couple of people said that it does better, on the recording. So I don't know if it does or not. But anyway, I'm going to go ahead and go over a couple of these, and then we'll do some examples. So I'm going to get out of this and go back to my handy dandy document cam, and I want to cover the antiderivative of a constant. The antiderivative of a constant is always going to be the constant times x. So if I give you the antiderivative of 2 dx, then that is going to be 2x plus c. If I give you the antiderivative of pi, well, pi is 3.14 dx. So that's going to be 3.14 x plus c. So it doesn't matter what you're given. If this is a constant, I'm going to pull out my handy dandy yellow, make y'all bitch, yellow. If there's a constant here, and there's a constant here, then you can make it into that and into that. The derivative of the antiderivative of a constant is constant times x. Now you need to write that down. It's your first rule. The second rule, the antiderivative, and this is the meat. This is the meat of the sandwich right here. The power rule. The antiderivative of x to the n power is 1 over n plus 1 times x to the n plus 1 plus c, where n is not equal to -1, because that would give you an undefined function. Now I'm going to use my red marker because this is the meat and potatoes right here. If you don't learn this one, just like the power rule with derivatives, if you don't learn this one and learn how to rewrite a function and use the power rule, if it's a radical or an exponential or whatever, then you might as well just forget about 230 next semester. So let's do one.
You don't teach 230, do you?
I'm sorry, what?
You don't teach 230, do you?
No, there's a whole thing behind that. I'm not going to get into it. They want the upper level calculus classes to be taught at Pendleton. That's all
No.
I'm going to say. I want you to tell me what the reasoning is behind teaching an upper level class at the Pendleton campus. Doesn't make any sense. I've taught it at the Anderson campus several times, but then we get some new people in the math department and they believe that it's better to teach the upper level 230 and 141 and at the Pendleton campus.
That's dumb.
Yeah. So x squared dx. All right. So I'm going to plug it in, and I'm going to do 1 over 2 plus 1 x to the 2 plus 1 plus c, and that's going to give me 1/3 x to the 3rd plus c. Now, I have another way of doing it. I do this. I put, and I'm going to draw this in green because you can do this if you want to. I do x to the n plus 1 over n plus 1. That's what I do. Now, you don't have to do it that way. You can do it either way. But I find this to be a whole lot easier. So that would be x to the 3rd over 3. And it's the same. But that's the way I do it. So you can decide which way you like to do it. And like I say, if I were you, I would just make up some. And how do you make them up? You just make them up. 2x squared. But I'm going to get into 2x squared on the next example, because there's a constant rule you can use with 2x squared, or when there's a constant involved. So let's go to that next. So how about the antiderivative of 2x squared dx? Now, I got into this with derivatives with y'all. You can actually pull that 2 out. You can pull it, and you can see it better with an antiderivative, because the derivative don't really have a symbol. You just have y prime is equal. This one, you have this integral, and you can actually pull this out front. And now you just take the derivative of x squared. I'm sorry, the antiderivative. So that's going to be 2/3 x cubed plus c. Okay? So what about the antiderivative of negative 4x to the 5th dx? Well, that negative 4 can come out. X to the 5th dx, negative 4, x to the 6th over 6, negative 4/6 x to the 6th, negative 2/3 x to the 6th. Okay, so that is how you do the power rule. Now let's do a couple other ones, because you still, the sum and difference rule with derivatives, you can still do that with antiderivatives. I'll give you 2 examples here. The antiderivative of 3x squared plus 2x minus 6 dx. Now, this is real simple. You use the same thing that you use with derivatives. You break each one of these up into its own antiderivative. Now, you don't have to write all this out. I'm doing this because I don't know how many of you have ever seen antiderivatives before. So I'm breaking it up. And I'm going to pull the constants out. Now I want you, each one of y'all, I want y'all to do the next step. So 3, and take the antiderivative of x squared, plus 2 times the antiderivative of x to the first power. And this is x to the 0 power. And I'm going to rewrite everything. 3 parentheses plus 2 parentheses minus 6 parentheses. All right, I'm going to do the derivative in green. Just so the antiderivative, when I say derivative in this section, you know what I mean. I mean antiderivative. Okay, so what is, that's going to be x to the third over 3. That's going to be x squared over 2. And that's going to be x to the first over 1. Now this one just worked out to where the 3's cancel and the 2's cancel. So your final answer is x to the third plus x squared minus 6x. Now, if you ever want to check an antiderivative, all you have to do is take the derivative. So I'm going to take the derivative of this function, and I'm going to do that in a really, I have a pink highlighter. I'm going to use pink. So what is the derivative of x cubed? 3x squared. What is the derivative of x squared?
2x.
Minus 6. And then the derivative of constant would be dx. Look there. That's what we started with. So that's how you find or check to see if you've got the correct antiderivative. Okay, now what happens if you're given something like this? F of x is equal to, I'm sorry, I'm in derivatives again. The antiderivative of x minus 1 times x plus 3 dx. One thing you're going to realize about antiderivatives is that the rules for antiderivatives, you have less rules for antiderivatives than you do for derivatives. In other words, you're not going to be able to use like the product rule with this. Okay? So you're going to have to rely on your algebra and change it to a trinomial. X squared plus 3x minus x minus 3 dx. X squared plus 2x minus 3. And now you have sum and difference. And I'm just going to go through and put x squared dx plus 2x dx minus 3 x to the 0 dx. And now you can take the antiderivative, and that's x to the third over 3 plus 2x squared over 2 minus 3x to the first over 1, x to the third over 3 plus x squared minus 3x plus c. Now, I've just covered several examples of the constant being pulled out front and you dealing with the terms, okay? And we'll just look over what we just did. Let me get rid of that. That problem, you had two binomials and you used the FOIL method. That one is a trinomial. And it's almost like the one we just did. And then you had here, you had two regular terms, and I pulled the constants out. So these are your basic term rules, okay? Your basic term rules. Now, what happens when you don't have just a regular term? Well, you either rewrite it or you have another general rule. So far, we've went over two general rules. What's the two general rules? We went over the constant rule, the antiderivative of k dx is equal to kx plus c. And we went over the power rule. Antiderivative of x to the n dx is equal to x to the n plus 1 over n plus 1. That's the way I do it, where n is not equal to -1. What happens if you have the antiderivative of 1 over x dx? Well, that's equal to the natural log of x plus c. We'll get into one of those in just a minute. And one of the last general rules, 4, the antiderivative of e to the a times x dx is equal to ae to the ax over a. Now, you can actually say, remember when I told y'all back a while back that the derivative d dx of e to the x is equal to e to the x? Remember me telling y'all that? And I also told y'all that the antiderivative of e to the x is equal to e to the x? Well, that's true. Because what is this right here? That's a 1. And put that over 1. See? It works out. But if this is a 2 or a 3 or a 4, you've got yourself a different animal. Okay? The derivative of e to the x, when that's a 1, is e to the x. The antiderivative of e to the 1x is e to the 1x. Because 1, what's the derivative of 1x? 1. And you multiply by 1. So 1 doesn't change anything. So this general rule is okay to remember, but it's better to understand that this rule gives you this right here. And that's why it's better to remember this rule just as it is to remember the chain rule with e to the x, with the derivatives. All right, so let's do another example. Come on, everybody got that? Everybody got number 4 written down?
Yeah.
Yeah.
Okay. So here's an example, and we're going to do just 2 or 3 of these, because this will get you through the 4.1 homework. Antiderivative of x to the third plus 4x. And the antiderivative of e to the 3t dt. All right, take a minute and do those 2 problems. So 231. Class is over. Okay, 11.
You have a work email.
Okay, so I'm just going to that's going to be the antiderivative of x cubed plus 4 antiderivative of x to the first, and I'm just going to put all that in parentheses with dx, so I ain't got to write dx twice. And that's going to be x to the fourth over 4 plus 4 times x squared over 2 plus c. And you could rewrite this. If you don't like x to the fourth over 4, you can rewrite that as 1/4 x squared, x to the fourth, sorry. Plus, well, the 4 and the 2 will cancel. And yes, you do have to do this. If you don't, you'll get reprimanded. Plus 2x squared plus c. And that is the 4 right there, 4. Now remember, when you do e to the x, it's going to be e to the x over x. So that means that I'm going to do, and I'm going to put the property right below it in peach color. The antiderivative of e to the ax is equal to e to the ax over a plus c. There's the rule. So that's going to be e to the 3t over 3 plus c. Or, if you don't like that, 1/3 e to the 3t plus c. Question. Now, 4.1 is very important, because 4.1 is like the footing. If you don't do 4.1 and do it and know it, then it's going to be very difficult to do the rest of chapter 4. Remember, negative exponents and rational exponents. Well, y'all should be saying right here, oh, I know this because Hubert taught us this. What I tell you about radicals and calculus? Calculus and radicals don't what? Calculus and radicals don't mix. So you have to rewrite it. What do you mean, Hubert? Well, if you've got x to the negative n, you could rewrite that as 1 over x to the n. Now that's for algebra to make it look pretty. Okay? Remember your algebra teacher telling you that you always want to have a positive exponent? Y'all remember that? Well, in calculus, we don't care. All right? In calculus, you want to use the opposite of this. If you have x, let's say you have 1 over x to the 5th. They give you 1 over x to the 5th like that. No. In calculus, you're going to change that to x to the negative 5th power. Because in calculus, you can work a whole lot better with this than you can with this. All right? Now, to make it pretty at the end of the problem, yes, make it pretty, bring that down. But when you're doing calculus, you want to have a base a x to the n. This is what you want. You want a coefficient, you want a variable, and you want an exponent, whether you're doing the derivative or the antiderivative. So if I have 2 over x to the 5th, I want 2x to the negative 5th in calculus. Or if I have 1 over 3x squared, that's 1/3 x to the negative 2. Same thing with radicals. Nth root of x to the first power, x to the exponent, that's equal to x index, exponent over index. So that's going to be 1 exponent over index. So the square root of x to the first power is equal to x to the 1/2. The third root of x to the 5th power is equal to x to the 5/3. This is what you want in calculus. You do not want ever a radical unless you want to finish it up with a radical. Then you finish it up with a radical. But when you start a problem, you want it to look like this. And you want it to look like this. You do not want it to look like this, and you do not want it to look like this, unless you're finishing up the problem. So, here's an example. Antiderivative of 9x squared plus the square root of x. And yes, this is a test question. This is one that I would put on a test at least 50 times. Okay? So the first thing you do, you don't even think about doing any calculus yet, because the first thing you should be thinking about, and we should put this in a little cloud right here, meaning that you're thinking about it, just like with derivatives, rewrite. Rewrite. So the first thing I'm going to do is I'm going to pull that 9 out front. X squared dx plus the antiderivative of x to the 1/2 dx. I just rewrote that problem. And now 9x to the 3rd over 3 plus x to the 1/2 plus 2/2 over 1/2 plus 2/2. Now, I have to do this because what do y'all do as students when we do an exponent that's a rational exponent? What do y'all do as students? What do y'all naturally do as students when I throw a fraction in an exponent? What do y'all do?
Give up.
There you go. You pretty much go, y'all just start slobbering all over yourself and you don't know what to do. Okay? So you add 1, n plus 1 over n plus 1. You know you got to have a common denominator, so you just change it. And you'd be surprised on how many students, when I get to this point, if I didn't put that in there, and I got to 2/3 x to the 3/2, I would leave half the class. And they'd go, well, I don't understand. Okay? So I'm putting that in there for those that forget. And y'all do forget. So here we go. So let's go ahead and knock out that 9 and that 3. And that's going to be 3x cubed plus x to the 3/2 over 3/2. Now what do you do when you divide by a fraction? Multiply by a reciprocal, Hubert. That's right, class. That's your answer. I got sunlight coming in through my windows. Sorry about that. All right. So let's try nerd. I'm going to give you another page for this one because some of y'all might need it. Because that's a test question, and this next one's going to be a test question. I'm checking the time because I don't want y'all to go into convulsions. Plus, you don't have to go into convulsions. We could actually have a 2-hour class if we wanted to. But of course, some of y'all would have a fit. All right, so here we go. Here's another test question. Antiderivative of 3 over x squared minus 1 over x dx. Y'all might as well just what?
But
Yeah, y'all might as well not even try this one. I don't know why my autofocus. There we go. It's working. Oh, I know why. All these papers over here, that's messing up the autofocus. Y'all should see how many of these papers I've got. I've got like a whole ream of paper just in the last 2 weeks. I'm thinking about getting a whiteboard. What do y'all think? Get a little
I think it'd
whiteboard.
be nice to watch movies on.
Look at all
I
this.
think a whiteboard's good.
Look at it. That's just 1 week. 1 week.
Yeah, you
Five
should get a
questions.
whiteboard.
I'm sorry, what'd you say?
You definitely should get a whiteboard if you're using that much paper.
Maybe I ought to get a piece of poster board. Have a poster
Yeah.
for y'all. How's those posters coming along? You got any teachers showing you posters? Don't even get me started.
I haven't.
No, it'd be kind of hard to show a poster. That's what Tri-County Tech was pushing. My dean asked me how things were going, and I said, I emailed him back. I said, I'm trying to figure out how to do a poster online. I didn't get a reply back. I don't think he appreciated it. Well, you can understand why I was
How many
frustrated.
Sharpies have you thrown away?
Say again? What
I
did you
said,
say,
how many
Billy?
Sharpies have you gone through?
Right now,
How many Sharpies?
the last week, these are all dead. So that's what, 5, 6. I've gone through 6, 4 black ones. So I'm gonna have to stock up on black. My colors don't go out as much because I use the colors to kind of differentiate stuff. So they don't go out, but the black ones, they go out. But I love the smell of I love the smell of them. Okay. So, here we go. There you go. That's all you got to do. Rewrite. Let me use my red one because that's the first thing you should think of. Rewrite. So I'm going to write this out, and the reason I'm going to write it out is I'm not insulting your intelligence, but I'm going to show you what you need to think about. 3x to the negative 2 dx minus 1 x to the negative 1 dx. 3 parentheses x to the negative 2 plus 1 over negative 2 plus 1 minus 1 x to the negative 1 plus 1. Okay, this right here, we can't do this because you say right here negative 1 plus 1, and what does this do to this function? Well, it blows it up. Okay, and when you get to this and you say to yourself, uh-oh, can't do this, then you go back to this and you say there must be a general rule for this, and it is, this is actually 1 over x, remember? Okay, so in this case, we don't need to write this one over, all right? This is natural log of x. So I'm going to rewrite this, natural log of x. The antiderivative of 1 over x is natural log of x. Now, I didn't do that at the beginning of the problem because I wanted to show you what actually happens when you do this and you come to this point and you see negative 1 plus 1 will give you 0, and that will blow this function right here up. Well, you can't just say, oh, well, it's blown up, you can't do it. No, we ain't got to that point yet. So you can't do that. So you have to refer back to the general rule of 1 over x, which means the natural log of x. So I kind of went around the world here to show you this, but I wanted to show you that if you come up with something that doesn't make sense, chances are you need to go back and use a general rule. So 3, and that's going to be x, negative 2 plus 1 is negative 1 over negative 1 minus the natural log of x. And negative 1 times 3 is negative 3 x to the negative 1 minus natural log of x.
Hi there.
Hi there.
It's currently 10:50.
Okay? And that can be rewritten as negative 3 over x minus the natural log of x. Now I'm going to circle this one, and I'm going to circle this one because you could rewrite that answer either way. I'm going to spend I got 10 more minutes. I'm going to go ahead and spend them on doing these next few problems because it's not going to hurt you, because it's very important that y'all work on 4.1 as soon as possible after you finish your test. Okay, here's two more examples. We've already done one like this one. Antiderivative of x minus 1, in fact, I think it's very similar, x plus 3. I'm going to let y'all do that one because we've already covered the, and that's going to be antiderivative of x squared plus 3x, or plus 2x minus 3. Didn't we do that one a while ago? Signs may be different.
Yeah.
Check the signs and make sure. Anyway, I'm going to let y'all do that one because I think we did that one. The answer is 1/3 x cubed plus x squared minus 3x plus c. Okay, that's not the one I want to get to. The one I want to get to is the next one. And I'm going to write it on another page because you might need it on a whole page. Y'all got C? Y'all got the end of that one?
Mm-hmm.
All right, here you go. This is the test question. And the antiderivative of 2t to the 4th plus 3 over t to the 3rd plus 14 over t to the 1/2 dt. So y'all might as well just forget it. There ain't no way y'all gonna get this one because it's got too many fractions in it. Got one. Got one fraction. That's too many. All right, what'd you get? Well, first of all, you need to rewrite it. I'm going to switch to another color because that brown is starting to get a little bit wide on me. Let's see if I can find one that's a little bit sharper. Let's see if I can do a purple. Purple! I'm going to have to throw away all my Sharpies because I've got mixed up old ones with new ones. All right, so 2t to the 4th dt plus 3t to the negative 3rd dt plus 14t to the negative 1/2 dt. Now I am writing everything out, so you do not have to write every single step down. All you need to do is do whatever you feel comfortable doing. So here we go. I'm going to write the derivative or the antiderivative doing that process I'm going to do that in a green color. Okay, so 2 antiderivative plus 3 antiderivative plus 14 antiderivative. So that's going to be t to the 4 plus 1 over 4 plus 1. T to the negative 3 plus 1 over negative 3 plus 1. That magenta and that green clashes. I do not like that. T to the negative 1/2 plus 2/2 over negative 1/2 plus 2/2. Yeah, y'all might as well just forget that last one. Now we can rewrite it as 2 t to the 5th over 5 plus 3 t to the negative 2 over negative 2 plus 14 t to the 1/2 over 1/2. Yeah, I do not like that magenta with that green. But it might have to do with I don't like Christmas songs until December 1st. So maybe that's why. I know, I'm weird. My daughter's the opposite. She says Christmas songs should be played after Thanksgiving dinner. I'm like, oh, no. And heaven forbid if I go into a store and they're playing Christmas music, oh my gosh, I can't handle it. Any of y'all like that?
Yeah, I feel like people try to rush Christmas and skip Thanksgiving.
Yep.
I don't like that.
All right. So here we go.
Yeah, it was like this year they started playing Christmas music before I think it was Halloween.
Yeah.
I noticed that too, like they'll put the Christmas decorations out with the Halloween ones, and I'm like, what? Doesn't make any sense.
2/5 t to the 5th. And I'm just putting that t to the 5th in parentheses. You don't have to do that. I'm just doing it just to kind of help out. Okay, minus 3/2 t to the negative 2. And we're going to address the negatives in just a minute. What happens when you divide 14 by 1/2?
You multiply it by 2.
Multiply it by 2, that gives you 28 t to the 1/2. And the only other thing that I would do is I would bring that t set. You don't have to, but I would bring this down, and my final answer would be 2/5 t to the 5th minus 3 over t 2t to the 2nd plus 28 t to the 1/2. Plus c. Now you don't have to worry about the plus c that much when you're doing your homework because the plus c is in your answer. And you see the plus c outside of the box, so you don't have to worry too much about that in your homework. I'm going to cover one more problem, or I'm going to write down one more example, or I'm going to write down, let's see. Yeah, I got one more example, and I'm going to let y'all do it, and then you can work on your 4.1 homework. And that example is a good test question here. Antiderivative of 3x cubed minus 4x plus 6 over x dx. Now I'm going to start you off. I'm going to divide everything by x. Oops, I'm sorry. I'm going to divide everything by x. So you could do this. Antiderivative of 3x cubed over x minus the antiderivative of 4x over x plus the antiderivative of 6 over x dx. And I want you to take your highlighter and I want you to highlight this right here because this will turn into something else. So 3 antiderivative of x squared minus 4 antiderivative of 1 pretty much dx, and that's a dx right there, plus 6 antiderivative of 1 over x, ding, 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 and I'm going to put that in green. And now you should be able to finish it. So let's take a minute or two and finish it. Go ahead. I want y'all to take, let's see, it's 11:02. Oh, 11:03. Go ahead, give you a minute. And at 11:03, we'll finish it. And then that'll be the end of class today. And that'll get y'all started on 4.1. There's only 4 sections in chapter 4, so we should be able to get through chapter 4 pretty easy. And whatever's left, I will give you a test on whatever's left on whatever time we have. So if I go over one section of chapter 3, then your last test on the last day of class, it starts on the last day of class, will be on that one section. But I'm going to try to get through this section pretty quick. Because it's not really, if you beat your head up against the wall with derivatives, then you should understand antiderivatives. Okay, it says 11:03. So 3 times x cubed over 3 minus 4, and this is a x to the 0. So that's going to be x to the first over 1. And what is the antiderivative of 1 over x?
Natural log of x.
There you go. And then, of course, this is really going to clash. It's going to make my head hurt. Red and magenta. Ooh. Okay, you can't tell it. All right, the 3's cancel there, and that leaves x to the third minus 4x plus 6 natural log of x plus c. Now, some of y'all should be saying to yourself, well, this ain't very difficult. The reason it's not very difficult is because you busted your rear end in chapter 2.
Shouldn't that 4x be 2x squared?
It shouldn't, I don't think, because what happens to the x's right here? Y'all check me. The x's cancel. Up here,
Oh, okay.
divided by x.
I forgot that part. I wrote
That's
it down,
all right.
but I wasn't.
That's all right. Okay. Now I have an application problem, but I'm not going to go over that. We can go over that Thursday. But I want to get into 4.2 on Thursday. And any homework questions that you send me. Anybody got questions? All right, the test is up. There's 20 questions, I think, 20 or 22. I can't remember. And they're pretty straightforward. They come from the homework. And you got 3 tries. So learn from your mistakes. Oh, and I did put, because I do know that people have been going outside the test to go to homework and stuff like that. So I cut that out. So if your cursor goes outside of the test, it's going to automatically stop. I had to do that because some of the Pendleton students were doing things they weren't supposed to. They think I'm crazy. They think I'm not going to find out. Anyway, sorry, Pendleton campus does that. I'm not talking about Pendleton in here. Pendleton campus in general, they screw it up for everybody. I hate to say that, but they do. Does anybody have any questions or any concerns? No questions or concerns or anything? Okay.
No.
Well, send questions on 4.1 Thursday, and I will see y'all Thursday, okay?